When you think about it, sailing seems pretty simple. You put up a big sail, the wind pushes it, and off you go. Easy, right? It's an idea that's been around forever. But here's where it gets weird. What if you need to go in the exact same direction the wind is coming from? How in the world can you move forward against the very force that's supposed to be pushing you backward? It sounds totally impossible, but it's not. So let's get into the incredible physics that make it happen. Okay, so here's the problem in a nutshell. Sailing downwind, that makes perfect sense. The wind's at your back like a giant invisible hand giving you a shove. But sailing upwind, that just feels wrong. It's completely counterintuitive. And for most of history, it really was impossible. For thousands of years, the wind was basically a one-way street. It determined where you could trade, how far your empire could reach, pretty much the boundaries of the entire known world. If the wind wasn't blowing your way, well, you just weren't going. I mean, think about those options. Seriously, you either had to just sit there and wait, sometimes for weeks, for the wind to finally change, or you could try to fight it with pure muscle, rowing until everyone collapsed. And a lot of the time, you just had to call it quits and go home. But then, around the 2nd century, this absolute game changer came along. It was a new kind of sail, a triangular one called the lateen sail. Now, unlike the big old square sails that could only get pushed from behind, this one could be angled. And that small change meant it could do something that felt like magic. It could slice into the wind. This was the very first piece of the puzzle. And that brings us to the real secret. See, it's not about the wind pushing the sail like a parachute. The trick is to make the sail act like an airplane wing and generate a force called lift. And the whole idea rests on this one beautiful principle from a guy named Daniel Bernoulli. It's simple, but it's so powerful. Faster moving air has lower pressure than slower moving air. That's it. That one little difference in pressure is the invisible engine that can drive a massive boat against the wind. Let me show you what I mean. So check this out. Because the sail is curved, the air going around the outside has to travel a longer distance, so it speeds up. And what did we just learn? Faster air means lower pressure. So you get this low pressure pocket on the outside of the sail. Meanwhile, you've got higher pressure on the inside pushing outwards. So get this, the boat isn't being pushed forward, it's actually being pulled into the vacuum it's creating. Wild, right? Okay, so now we've created this awesome force. We're generating lift, but that's only half the battle. Because the next super clever part of this puzzle is figuring out how to actually control that force and make the boat go where you want it to. And here's the problem. That lift force doesn't pull the boat straight ahead. Nope. It actually pulls it mostly sideways and just a little bit forward. If that's all there was to it, you just end up skidding sideways across the water. Not very useful. But we can break that one diagonal force down into 2 parts. You've got the part you really want, that little bit of forward thrust. And then you've got all this sideways slip that you desperately need to get rid of. Which leads us to the next big question, right? How do you build a boat that can fight against that massive sideways push so you can turn all that lift into forward motion? The answer is brilliant. It's called a keel. And the best way to think about it is like the blade on an ice skate. That blade digs into the ice, right? It lets you glide forward easily, but it makes it really hard to slip sideways. The keel does the exact same thing, but in the water. It just grips the water and refuses to move sideways. But wait, the keel actually has 2 incredibly important jobs. First, its shape stops the sideways slip, but all that force from the wind is also trying to tip the boat over. So the bottom of the keel is packed with tons of heavy weight. We're talking thousands of kilograms of lead called ballast. It's a massive counterweight that keeps the whole thing from flipping over. All right, so we've got the hardware down. A sail that's basically a vertical wing, and a keel that's like an underwater ice skate. Now we just need the technique, the final piece of the puzzle that lets sailors march straight into the wind. Now, even with all this clever physics, there's a limit. You just can't sail directly into the wind's eye. There's this area called the no-go zone where you're pointed too far into the wind for the sail to work. You try to sail there and you'll just stop dead in the water. So how do you beat it? Well, you kind of have to cheat. Sailors use a move called tacking. What they do is sail as close as they can to that no-go zone to build up as much speed as possible. Then they make a quick, sharp turn right through the zone so the wind catches the other side of the sail. You just keep repeating that elegant zigzag, and bit by bit, you climb your way upwind towards a goal that should be impossible to reach. So when you put it all together, the sail, the keel, the technique, What do you get? It's so much more than just a clever boat ride. You get a technology that literally changed the entire course of human history. Solving this one problem didn't just make sailing better, it unlocked the whole planet. All of a sudden, the oceans weren't one-way streets anymore. They were two-way superhighways. This is what made it possible for explorers like Columbus to actually get home. It's how navies could outmaneuver each other in huge battles like the Spanish Armada. It's what powered those legendary, record-breaking clipper ships. And believe it or not, the story isn't even over. I mean, get this. The efficiency of modern sailboats is just mind-blowing. By perfecting these same exact principles, some high-tech racing boats can travel at almost 3 times the speed of the wind that's pushing them. It's incredible. They create so much of their own wind that it just keeps making them go faster and faster. And now things are coming full circle. To cut down on fuel and emissions, these ancient ideas are making a huge comeback. Modern cargo ships are being built with giant kites, fully automated sails, and even these crazy spinning rotors that use the exact same principles of lift to help push these behemoths across the ocean. You know, whether it's an ancient sailor figuring it out with a simple piece of cloth or a modern engineer with a spinning metal tube, the fundamental challenge is exactly the same. It's about the pure genius of taking the very force that's standing in your way and turning it into the thing that propels you forward. And really, that's what it all comes down to. It's a story about human curiosity, about refusing to be limited by nature, and instead trying to understand it, harness it, and then just see how far we can possibly go.